Madhu Sarvani. So today I am going to explain about various algorithms and their common features and their program features. So the first one is bubble sort. It compares each pair of adjacent elements and swap them if they are in a wrong order. It repeats this process multiple times until the whole list is sorted. And next is selection sort. It looks for the smallest element in the list and swaps it with the first unsorted element. Then it keeps repeating this process. The next one is insertion sort. So it builds a sorted list by taking one element at a time and placing it in the correct position among the already sorted list of elements. Next is merge sort. So it splits the list into two smaller lists, sorts them and then merges them back together. And it is an efficient and works well even for a large list. Next is quick sort. So it picks a pivot element, then splits the list into two parts and sorts both parts. So it is fast when the pivot divides the list evenly. It is slow if the pivot is poorly chosen. And next is linear search. So it checks each element in the list one by one to find the target element. It is fast if the target is at the beginning and it is slow when the target is not in the list. And next one is binary search. It works on a sorted list. It checks the middle element and decides whether to search the left half or the right half of the list, repeating this process until it finds the target. It is very fast because it halves the list every time. And next is array. An array stores a fixed number of elements in a continuous block of memory. You can access any element directly using its index. So there are various operations can be performed on an array. So the insertion and deletion can be slower if you need to shift elements around it. And next comes the linked list. Single linked list. So it stores element as node where each node points to the next one. You can insert or delete nodes easily at the beginning, but accessing elements takes longer since you have to follow the links. So it is easy to add and remove items, but finding an element requires going through the list one by one. And the next one is double linked list. It is a single linked list, but each node has two pointers, one to the next node and one to the previous node. This allows traversal in both directions. You can easily add or remove items from both the ends and anywhere in the list. And the next is circular linked list. It is a linked list where the list node points back to the first node, forming a circle. You can keep traversing the list endlessly, but finding an element still requires checking each one by one. And next one is stack using arrays. So a stack works on the last in first out principle. You can add or remove, that is push or pop items from the top and peek at the top item. So you can add or remove elements only from the top of the stack. And next one is stack using linked list. It works like a stack, but instead of using an array, it uses a linked list to store elements. The same as stack array, but the size is dynamic and can grow without the fixed limit. And next is queue using array. Queue works on the first in first out principle. You can add items to the back and remove them from the front, that is NQ and DQ. So operations of queue using arrays includes items are processed in the order where they are added. Next is queue using linked list. Like a queue, but it uses a linked list to store the elements, making it more flexible in terms of size. So there are various operations that is same as the queue array but uses pointers to link elements. And the last two is binary tree. So a tree where each node has at most two children, that is left and right. It uses to organize data hierarchy. So you can insert, delete and traverse the tree in different ways, that is in order, pre-order and etc. Last but not least is binary search tree. It is a special binary tree where the left is always smaller than the parent and the right child is always larger. This property makes searching faster. The operations like searching, inserting and deleting are quick, but they can be slow if the tree is unbalanced. So in simple terms, we can say that sorting algorithms helps organize and searching algorithms help find data, and data structures are ways to organize and store the data, with each structure being good for certain tasks like adding, deleting or searching. Thank you.